What if the most powerful network on Earth isn't Google or the Internet, but something living in the soil right beneath our feet? How can trees hundreds of miles apart share resources, warn each other of danger, and even engage in silent biochemical warfare? Today, we reveal the secret global network of fungi, a system so complex it may force us to rethink everything we know about life on this planet. For most of us, fungi are remembered for one thing above all else: poison. In reality, fungi are far too diverse to fit into a single category. Today, the scientific community estimates that there are hundreds of thousands of fungal species. Only a very small fraction of them produce deadly toxins. By contrast, the vast majority are either completely harmless or directly beneficial to humanity. Humanity has used mushrooms as food for thousands of years. Button mushroom, oyster mushroom, morel mushroom, porcini mushroom, shiitake mushroom. These are edible, non-toxic mushrooms. Beyond being safe to consume, they are also rich in protein, fiber, vitamins, and minerals. These fungi grow by decomposing organic matter in nature and develop structures compatible with the human digestive system. Their difference from poisonous species lies not only in their chemical composition, but also in their cellular structure and metabolism. Some mushrooms are not eaten, but this does not mean they are poisonous. Many species are simply too hard to digest, structurally indigestible, or lacking any nutritional value. These mushrooms generally play a role as decomposers within ecosystems, helping regulate soil structure and complete nutrient cycles. They are not food for humans, but they are indispensable for nature. Some mushrooms are direct sources of medicine. Antibiotics, one of the cornerstones of modern medicine, were first obtained from a fungus. In addition, numerous compounds that support the immune system, reduce inflammation, or influence cell regeneration have been isolated from fungi. These types of mushrooms may be inedible and are not used as daily food, but they are extremely valuable from a biochemical perspective. Why is the perception of poison so dominant? Despite all this diversity, why do we still primarily remember fungi as poisonous? Because in nature, the margin for error is low. Choosing the wrong mushroom means exposure to the wrong chemical compound. The human brain generalizes this risk for safety and places the entire group under a single label. Scientific thinking, however, does not generalize. It distinguishes, classifies, and evaluates each species within its own context. At this point, we see this truth. Fungi are not simply poison. They are not simply food either. They are an extremely complex group of organisms that carry nature's chemical diversity. And this complexity makes them organisms to be understood, not feared. Up to this point, we have mostly treated fungi as individual organisms, classifying them as edible, inedible, harmless, or used for medicinal purposes. However, the true importance of fungi in nature lies not in what they are, but in how they function. The real impact of fungi appears not in the capped structures we see on the surface or in the chemicals they produce, but largely in the invisible structures beneath the soil. Every structure we perceive as a single mushroom is actually only a small part of a much larger system that can stretch for kilometers. For this reason, fungi should be understood not just as separate species, but as a network system that establishes connections within ecosystems. This perspective leads us to one of the least noticed but most effective structures in nature. The true body of fungi is often not the capped structures we see on the surface. These structures are only for reproductive purposes and are short-lived. The main organism consists of microscopic filamentous structures called mycelium that spread beneath the soil. When viewed individually, these filaments appear extremely simple. However, when they come together, they form dense and continuous network systems that can stretch for kilometers underground. This network may belong not to a single mushroom, but to a single living structure spread across an entire forest. The mycelium network does more than support fungal growth. It collects water, minerals, and various chemical compounds from its environment and transports them to different points across the network. In other words, mycelium functions not as a passive structure, but as an active transport and distribution system. This underground network is in direct contact with plant roots. Trees and plants connect to the mycelium network through their roots. Through this connection, plants gain access to water and minerals that would otherwise be difficult to reach. In return, plants transfer sugars produced through photosynthesis to the mycelium network. This is a mutually beneficial relationship. This system is not limited to nutrient exchange. Research shows that mycelium networks can also transmit chemical signals. When a tree is attacked by harmful insects, it can send warning signals into the network through its roots. These signals travel to other trees, allowing them to activate defensive responses before being attacked. For this reason, some scientists describe the mycelium network as the information transport system of forests. This is not conscious communication, but it is an extremely effective form of biochemical coordination. This underground system allows forests to function as unified wholes rather than isolated individuals. This is where the secret language of fungi truly emerges. It is silent, invisible, and often unnoticed, yet it plays a decisive role in sustaining life in nature. But what happens if this network is disrupted? Because the mycelium network lies at the heart of ecosystem connectivity, damage to it affects not only fungi but all organisms dependent on the system. When the underground network is disrupted, plants struggle to access water and minerals, nutrient sharing is interrupted, and trees experience prolonged stress. Over time, entire forest structures are affected. Damage to the mycelium network also disrupts chemical signaling between trees. Early warnings against pests are delayed or lost entirely, allowing infestations and diseases to spread more rapidly. As a result, a problem affecting a single tree can impact the entire ecosystem much faster than before. The mycelium network also directly influences soil structure. It increases water retention and reduces erosion. When the network weakens, soil dries out more quickly, nutrients are lost, and root systems become unstable. By the time surface-level symptoms appear, the underground system has often already suffered serious damage. Human activity plays a significant role in this process. Intensive agricultural practices, constant soil tilling, and chemical fertilizers physically disrupt mycelium networks. Each disturbance breaks connections, and when damage occurs faster than the network can repair itself, the system begins to weaken. Pesticides and fungicides do not affect only targeted organisms. They also harm beneficial fungi, reducing the effectiveness of the network. While short-term productivity may increase, long-term soil health declines, leaving ecosystems more fragile. Forest fragmentation caused by roads, settlements, and mining further weakens these systems. As forests are divided into smaller sections, mycelium networks lose their ability to spread across large areas and connect ecosystems. As a result, forests begin to function not as unified systems, but as isolated fragments. Most of these effects go unnoticed in the short term. This is because the mycelium network is invisible to the human eye. Over time, however, increased disease, declining soil fertility, and sudden ecosystem collapse reveal the consequences of these hidden disruptions. Human influence often appears not through direct destruction, but by weakening the connections that sustain life. What we have seen so far is that fungi are not just poisonous or edible organisms. They sit at the center of complex and invisible systems operating beneath the soil. Through these systems, forests cease to be mere collections of trees standing together, and instead become integrated networks where water, nutrients, and chemical signals are shared. When such a central system is damaged, the effects are not limited to a single species. Changes in soil structure, forest fragmentation, and chemical interventions directly affect these hidden networks. Often, the damage we notice on the surface begins much earlier beneath the soil. When a forest collapses, the problem is not only the trees, but the network of relationships that once connected them. When those connections fail, ecosystems lose their balance. For this reason, viewing fungi only as poison or as a food source is an incomplete perspective. They are fundamental components of the connection systems that sustain life in nature. Truly understanding nature requires looking not only at what we see above ground, but also at the structures silently operating beneath our feet.